Overview of operating system. So first, what is an operating system or an OS? An operating system or OS is system software that manages computer hardware, software resources, and provides common services for computer programs. It serves as an interface between the computing system and the end user. Operating systems are found on many devices that contain a computer, from cellular phones and video game consoles to web servers and supercomputers. So, this is a visualization of the operating system. The hardware is not a part of the operating system, but it is the physical device that we use. So the only part of the operating system is the user space and the kernel space. So user space is all about the applications. Examples are the Microsoft PowerPoint, Microsoft Word, Notes, etc. And then we have the kernel space, which consists of four parts: the process manager, memory manager, file manager, and IO manager, or the input output manager.
Who is the father of operating system? Gary Arlen Kildare was born on May 19, 1942 and died in July 11, 1924. Was an American computer scientist and microcomputer entrepreneur who created the CP/M operating system and founded Digital Research Incorporation. What was the first PC-based operating system called? The first IBM PC, formerly known as the IBM Model 5150, was based on a 4.77 MHz Intel 8088 microprocessor and used Microsoft MS-DOS operating system. The IBM PC revolutionized business computing by becoming the first PC to gain widespread adoption by industry.
What are the most famous operating OS nowadays? So we have here a Windows, Macintosh operating system, or Mac OS, Linux, iOS or iOS, and Android OS. So let's discuss about basic difference and history of operating system Windows, Mac, and Linux. Windows was first released in 1985. It was supposed to be graphical user interface on top of MS-DOS. So MS-DOS stands for Microsoft Disk Operating System, and is also known as Microsoft DOS, or MS-DOS was the Microsoft marketed version of the first operating system to be widely installed on personal computers. And Macintosh or Mac. This operating system from Apple stands older than Windows. It was first released in 1984, so mas nauna na-release ang Macintosh kaysa kay Windows. It began as a graphical user interface right from its inception. In 2005, the design and structure of Mac OS was changed to Intel x86 based architecture. Linux. It was initially developed in Finnish University. It was released in 1991 and designed for GNU developers. GNU stands for GNU's Not Unix. GNU is an extensive collection of free software which can be used as an operating system or can be used in parts with other operating systems. File structure. Windows follows a directory structure to store the different kinds of files of the user. It has logical drives and cabinet drawers. It also has folders, some common folders like documents, pictures, music, videos, and downloads. All these files can be stored in these folders and also new folders can be created. It also has files which can be spreadsheet or any application program. It can give extension as text or .jpeg, etc. In addition to this, Windows also provides recycle bin where you can also restore the deleted files. Recycle bin can be configured to increase its size. Macintosh. The file structure of Mac is commonly known as the Mac OS X, Mac OS 10. If you go to dig into your Mac's hard disk through Finder, you will see many directories. The root directory of Mac may encounter when they visit their own MacBook. You can explore the file system and directory structure by going to directories like application, developer or /sbin or temp and etc. Linux. Linux has a completely different file structure from Windows and Mac. It was developed with a different code base. It stores data in the form of tree. There is a single file tree and all your drives are mounted over this tree. Registry. Windows Windows Registry is a master database which is used to store all settings on your computer. It is responsible to store all user information with its passwords and device-related information. The registry also has an editor which allows you to view all keys and values or even drivers if necessary. Unlike Mac, Mac stores all applications settings in a series of list files which have the various preferences folder in Mac. This list file contains all properties in either plain text or binary format. These are stored at library preferences and folder. Linux also does not have a specific registry of its own because all application settings are stored on a program basis under the different user in the same hierarchy format. Hierarchy format of the files being stored. There is not centralized database for storing these details and so periodic cleaning is also not required. Interchangeable interfaces. Windows interface was not interchangeable until Windows 8. Windows XP had some improvements but not par. Start menu, taskbar, system tray, and Windows Explorer. Mac has facility to bridge virtual network interfaces. This can be done by going to system preferences and managing the interfaces. Unlike Linux is easy to switch interfaces. You can switch the environment without having to carry all installations. So there are utilities like Genome and KDE which help in catering these needs. They help in focusing on different aspects. So, and last but not the least, command terminal. Windows, a terminal or command prompt is a black box ideally used to execute commands. Is it is also called Windows Command Processor. It is used to execute commands and different batch files. It can also be used for administrative functions and troubleshoot and solve all Windows issues. Macintosh. Mac provides a console as a terminal application. It has console command line, prompt, and terminal command line is used to type your commands. Prompt will provide you some information and also enable you to run commands, but terminal is the actual interface which will provide the modern graphical user interface as well. You can find terminal at the application utilities. So Linux also provides a terminal, but you can find the terminal at the applications, systems, or application utilities. In addition to this, there is also shell prompt, the most common shell used in Bash. It defines how the terminal will behave and look when it is run. When it is run. Let's talk about the difference in iOS and Android. We all know that iOS is developed by the Apple, while the Android it is based in Linux kernel and developed by the Google. So as you can see here, you can see the vulnerabilities between iOS and Android. So the iOS have 85% of top 100 iOS apps are vulnerable, while the Android has a 95% app 95% of 100 Android apps are vulnerable.
Principles of operating system. Purpose. It abstracts complex computer resources, and it provides hardware compatibility, and it protects the system. Interrupts is a request for the processor to interrupt currently executing code when permitted, so to be processed in a timely manner. If the request is accepted, the processor will suspend its current activities, save its state, and execute a function called an interrupt handler or an interrupt service routine (ISR) to deal with the event. Hardware interrupts initiated by hardware devices like keyboards or disks to indicate electronic or physical state changes that require time-sensitive attention. Exceptions initiated by the CPU happens when CPU reaches an instruction that it does not know how to handle. The operating system's response will be to kill the process. Software interrupts initiated explicitly by the running software interrupts initiated explicitly by the running program using a special purpose instruction designed specifically for triggering interrupts.
Linux file handling. In Unix-based systems, a process can interact with files through file descriptors, integer identifiers of files that the process has opened. For each process, the operating system maintains a table to track how file descriptors map to locations on the disk, but this table is not available for the process to see. Managing descriptors. For creating a file descriptor, Linux has the open system call, which takes two parameters, the file name and an int representing options to the system call. The open system call returns the integer file descriptor it creates or a negative number if the request file can't be opened. File disk, open file name, mode, close file disk. The closed system call allows a process to deallocate file descriptors. By closing the file, you are forcing the operating system to empty the buffer. Otherwise, if the program aborted abnormally, the change don't occur. The descriptor table maintained by the operating system has a limited size, such as 64. If you don't close your files, it can become full, and a later open system called fail. Reading and writing. To get information from a file, we use the read system call. This takes parameters, first the file descriptor, an int, then a pointer to an array of bytes, a char, and finally this integer saying how long the array is. It returns an int representing the number of bytes read from the file, 0 if it has reached the file's end, or negative integer in the case of an error. The write system call is quite similar. Write file this but in bytes. It takes the file descriptor, an int, a pointer to an array of bytes, a char, and a integer saying how many bytes to write to the file.
Default descriptors. Every process has 3 file descriptors already defined for it before it enters the program's main function. 0 represents standard input, correspond to reading data from the keyboard, allows a process to receive input from the user. 1 represents standard output. Characters written to 1 appear on the display. 2 represents standard error. Characters written to 2 also appear on the display. The difference is that the system does not buffer the output as it does with the standard output, and so any characters written appear immediately. This is meant for reporting errors, which the user should see immediately. File descriptors refers to files instead of the keyboard and display. Is set up by the program that interrupts the user's commands and startup programs. This program is called the shell.
So we have here processes. So a process is an instance of a program running on the computer. Under processes, we have the process table. It stores what the OS needs to remember for each process. OS continually switches processes on and off the CPU, which records each process's registers since there are lots of processes in existence, typically 100 or even more at the same time. And it does only one instruction at a time, which then tells it which instruction to do next. So the purpose of the process table is to have organization of which instruction should be executed next. Each process table entry contains the following information, among other things: their process's status, their process's last observed program counter value. This is so that the operating system know where to begin when the program is run again. The last observed register value, so the data can be restored when it is used again. The process's file descriptor table, and a pointer to the next process in line. Next, we have context switching. So context switching, from the word itself, context, what it is all about, and then switching is to change what is it all about. So for example, suppose that a process is currently running on the CPU, or the central processing unit, but then it gets to a point that it wants to retrieve some data from an I/O device like the disk. So I/O device is an input-output device. In this case, the operating system will move the process from the running state to the block state and promote some ready process into the running state instead. This is called context switch. and it proceeds as follows. During a process's life, it goes through three states. So, in context switching, we have three states, which we can see in this visual. The running, ready, and blocked state. So, yeah. Moving on, we have preemption. It is to cut off a process after it uses the CPU for a certain amount of time, called its time slice, and put it back into the ready queue. This is represented by the arrow from the running state to the ready state in the state diagram. So, here we have the visual again. So this time we have preemption. It is the process or the arrow from running to ready. So that is preemption. To permit this, computer systems incorporate a clock device, a device with which the OS can schedule a hardware interrupt to occur after a certain amount of time. So, clock device. When you want to play a game, but then your device's specs cannot support the game you want to play, you can overclock your system. However, it is not advisable since it can have disadvantages to your hardware, such as overheating or whatnot. And then lastly, we have process scheduling. Process scheduling is a selection process when ready queue contains many processes. So from the word itself, the process or the step-by-step task is being scheduled. So what comes next? The simplest process scheduling algorithm is round robin, in which each process is treated equally. When one process runs its time slice out, it is simply placed at the end of the ready queue, and then the next process in line begins. In some systems, the concept of priorities is assigned to processes. So, we have here the diagram in which we can see that after running, it is preempted and then put to the ready queue. However, when a task or process is on the block state, in which because of a time slice out, it is placed in the waiting queues. After the time slice out runs out, it then goes at the end of the ready queue, and then after that goes to running again. So that is how the process happens for the algorithm round robin.
Linux process management. The operating system must provide some support for managing processes. We'll look at the system calls supported by Linux toward this purpose. One of them we have already seen, the exit system call, which allows a process to request that it be killed. Creating process. To start new processes in Linux, this is accomplished with the fork system call. The fork system call creates a duplicate of the currently running process. It is a complete clone. It has a new process ID, but the process table entry for the current process is copied into the clone's process table entry. It has its own memory space, but all the memory of the previous process is copied into the clone's memory also. Thus, the old parent process and the new child process are indistinguishable, except for the process IDs. They even both continue from the fork system call, since they have the same program counter values and the same memory values. Running programs. Sometimes we will want to run a different program entirely. For this, You can also use the execvp system call. When the system executes the execvp system call, it replaces the program run by the current process with the requested program. Shell. Under Unix systems, the program that reads user commands and start programs is not really part of the operating system. It is called the shell, and it runs as a regular user program. In fact, there is no reason that you can't write your own and run it. CPU scheduling algorithms. Types of CPU scheduling. Preemptive. Works by separating time allotments of CPU to a given interaction. Non-preemptive. Cycle takes the asset CPU time and holds it till the interaction gets ended or is pushed to the holding up state.
Scheduling terminologies. Arrival time. The point of time at which process enters the ready queue or state is called as arrival time, and it is denoted as AT. Waiting time. The duration process spent in the ready queue waiting their turn to get into the CPU is called as waiting time, and it is denoted as WT. Burst time. The duration required by the process to get executed on the CPU is called as the burst time, and it is denoted as BT. Completion time. The point of time at which process complete its execution is called as completion time, and it is denoted as CT. Turnaround time. Completion time minus arrival time. And it is denoted as TAT. Response time. It is the time it takes to start responding to a request, and it is denoted as RT. Throughput. Number of processes that are completed per unit time. And lastly, processor utilization. The percentage of the time that CPU is busy, means not idle.
Scheduling algorithms. The OS will have to control how CPU time and hence number of CPU instructions is allocated between different processes. It will have to schedule the different processes. First come, first served. FCFS. Whichever program is added to the queue first is run until it finishes. Then the next program in the queue is run, and so on. Shortest job next. SJN. It picks the program which will take the shortest amount of time as the one to run next. Priority scheduling. The OS assigns each program a priority. This could be based on how much memory they take or how important they are for maintaining a responsive user interface. The program with the highest priority is picked to run next. Shortest remaining time. Shortest remaining time. This is similar to shortest job next, except that if a new program is started, the OS compares the time it needs with the time the currently running program has left. If the new program would finish sooner, then the currently running program is switched out and the CPU starts processing the new program. Round-robin scheduling. Time on the CPU is divided into equal parts called time slices. Time slices are allocated to each program equally and cyclically. Multi-level queues. In this algorithm, programs are split into different queues by type, for example, system programs or interactive programs. The programs of each type form a queue.